Next we come to the concept of strong field ligands and weak field ligands. So this was a major limitation of a VBT, right? It could not explain why some fields were strong, why some ligands were strong, why some ligands were weak. CFT explains that. How it explains that? See, the value of del O, it varies. Okay, it's never constant for a complex. It always varies, and it depends upon, with many other factors, it also depends upon the ligands. So if the value of the del O is high, that means the separation between EG and T2G is high. That is, if the value of del O is high, so that means separation between the EG orbital and the T2G orbital is high. And if the value of del O is low, that means that the separation between EG orbitals and the T2G orbitals is less. So if the value of del O is high, I can say that the splitting is large. And if the value of del O is low, I can say that the splitting is less or the splitting is small. Now those ligands which cause a small splitting, for which value of del O is less, those are weak field ligands. Okay. So for the weak field ligands, the value of del O is low. Similarly, those ligands which produce a large splitting, those are known as strong field ligands. So for the strong field ligands, the value of del O is high. The value of del O is high, that means the splitting is large, so the difference between EG and T2G is high, because this is the entire del O. The difference between EG and T2G is del O. So this was the concept of weak and strong field ligands. So now we know why some ligands are weak field ligands and why some ligands are strong field ligands. That is why in some complexes pairing happens, why in some complexes pairing does not happen. That pairing also depends upon your del O only. We will see how it depends upon del O. If the ligands are arranged in an increasing order of the del O, then that arrangement is known as a spectrochemical series. This is the spectrochemical series. On going from left to the right, the value of del O or the magnitude of del O is going to increase. So I negative has the least del O, whereas in this series CO has the highest del O value. From here to here, the del O increases. This is a continuation. So after H2O, that is after H2O, NCS comes. So H2O's del O is lower in magnitude than NCS's del O. And after O-phenanthroline, NO2 negative come. That means NO2 negative's del O is higher than orthophenanthrolene's del O. So this is the spectrochemical series, and on the basis of that we can predict whether a complex is going to show pairing or whether a complex is not going to show pairing. But again, we need to know what is the concept behind pairing. It's not just that we take a ligand and we can predict that this is going to cause pairing, this is going to not cause pairing, for this del O is high, for this del O is less. No, there has to be a concept why it is causing pairing, why it is not causing pairing. So in the next coming slides, we are going to see that concept, why it is going to cause pairing and why it is not going to cause pairing.